Okay everyone, so in today's lesson we are going to talk about how to find the distance from a point to a line. An example question that you might get is this one. Find the exact and approximate distance from the point -4, -6 to the line y is equal to 2 over x minus 1. Let's go ahead and let's start by plotting this information on our grid over here. I'm going to start by plotting my point. -4, -6 is roughly right about there. I am then going to go ahead and plot my graph. I'm going to start at my y-intercept of -1. I'm going to go down 2 to the right by 1. Down 2 to the right by 1. We can go ahead and plot this. Again, this is just approximate. It doesn't need to be perfect. Okay, so we have our two pieces of information here. We have our dot and we have our line. The approximate distance, well, we can kind of see maybe it's going to be 2 units, maybe a little bit less if we go this way. I'm going to say approximately, I'm going to guess it's going to be about 1.5 units away from the line. Now when we need to find the shortest distance, there's a lot of kind of different steps we need to work together, okay? And it's very important that you have completed the distance formula investigation or the length formula investigation, or that you have an understanding of that before we begin here, because that's what we are going to be applying today. So to find the shortest distance, you need to imagine that you have a line through the given point that intersects the given line. So I need to put a line through my dot here that's going to intersect my line. This new line must be perpendicular to the given line. Let's just zoom in. Let's see if I can do it. Zoom in on the graph here. Okay. And I have my ruler here where I can imagine the distance between the point and the line. The shortest distance is not going that way, just like the shortest distance is not going this way. If we imagine this to be a bit of a pendulum here that's swinging and swinging and swinging, we can pretty clearly see that the shortest distance is when we have a right angle between our new line and our original line, okay? That's because our new line is going to be perpendicular to our new line, or to our given line. Any further, and it's going to be too long. We can imagine it swinging and swinging and swinging and swinging and swinging, and eventually we're going to land at a perpendicular spot, and that is the shortest. Okay, so as I said, this line, the new line that we are going to be creating here, has to be perpendicular to the line that you have been given in the problem. Then we need to find out what the point of intersection is of these two lines. Okay, the point of intersection, as we can imagine, is going to be somewhere right about here. Let me just mark that off with an X. It's going to be somewhere here. Okay. The distance between the given point, so my pink point, and my point of intersection, which is going to be around where that yellow X is going to be my shortest distance. And that's why it's important you understand the distance formula here. Okay? So there's a couple of steps in order to complete these types of problems. First and foremost, as I said, we have to find our second equation, okay? We need a second line here, a line that is perpendicular to the given line and that passes through this point. In order to find the equation of a line, we recall that we need a slope and we need a point. Well, we know the point. The point that we have is -4, -6. That is our given point. It has to pass through that. We now need to find the slope. We know that slopes that are perpendicular to other lines are going to be the negative reciprocal of the slope of the given line. So the negative reciprocal here is going to be of the value 2, because we recall that the slope of our given line is 2. So our slope is going to be the negative reciprocal of 2, which is going to be negative 1 over 2. Okay, we have those pieces of information. Now it's nice and easy to solve. I'm going to solve this way, where I have y is equal to mx plus b. I'm going to substitute in my m as well as my x and my y values. Negative 6 is equal to negative 1 over 2 times negative 4 plus b. Negative 6 is equal to 2 plus b. Negative 6 minus 2 is equal to b, and therefore negative 8 is equal to b. Now that we have our b value and we have our slope value, we know that the formula for the line passing through our given point and that is perpendicular to the given line is going to be y is equal to negative 1 over 2x minus 8. That is the equation of the line passing through this point and hitting our given line at a 90-degree angle. That's just step number 1. Now, as we said, we need to find the point of intersection between this line, our new one, and the given line, because that is the second dot, that is the second ordered pair that we need in order to find our distance between our given point and the line. So let's flip this over here. And we can now find our point of intersection. I'm just going to rewrite both formulas here so that we remember. Y is 2x minus 1, and y is equal to negative 1 over 2x minus 8. In order to find our point of intersection, I'm going to use the substitution method, and I'm going to substitute in this information for y in my first equation. This is going to give me negative 1 over 2x minus 8 is 2x minus 1. Now we just have to solve for x. I'm going to move my x's to the left, my whole numbers to the right. Negative 1 over 2x minus 2x is equal to negative 1 plus 8. Negative 1 over 2x minus 2x is a negative 5 over 2x. Negative 1 plus 8 is 7. I'm going to multiply both sides by 2. Okay, in order to clear my denominator. And I'm going to divide both sides by negative 5 to give me x is equal to negative 14 over 5. Okay, now I can go ahead and I can find the y value of my point of intersection. Remember, we can find the y value by substituting this information into either one of our equations. So I'm going to go ahead and do that. I'm going to substitute it into the first one. Y is equal to 2 times negative 14 over 5 minus 1. This is going to be y is equal to negative 28 over 5 minus 1. I find my common denominator here to give me 5 over 5. I can then subtract. Y is equal to negative 33 over 5. So my point of intersection is going to be negative 14 over 5, comma, negative 33 over 5. This is a pretty messy number, and I promise you not all questions are going to be as messy as this, but we're kind of going with the hardest one possible so that you can see that and appreciate easier questions next. Now we need to find the distance between our 2 points. Our 2 points, as we recall, negative 4, negative 6, and negative 14 over 5, negative 33 over 5. Okay, some of you might want to clear these fractions, multiply everything by 5. That's not how this works. The only reason that you can do that in some circumstances is because you are dealing with an equation. We are not dealing with an equation yet here. And this is our application for our distance formula. Our distance formula, d, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, those are the 2 points that I have here, so I'm going to call this x1, y1, x2, y2, and we can start substituting in some information. x2 here is negative 14 over 5 minus negative 4 all squared plus negative 33 over 5 minus negative 6 all squared. Okay, let's go ahead and evaluate, just keep working through. Negative 14 over 5 plus, because we have a double negative, and I'm going to change this immediately to be 20 over 5 squared plus, then we have negative 33 over 5, again plus, and it's going to be 30 over 5 with a common denominator, and this is all squared. Let's keep going. Okay. Negative 14 over 5 plus 20 over 5 is 6 over 5. That's going to be squared. Plus negative 33 over 5 plus 30 over 5 gives me negative 3 over 5 all squared. So my square root sign can end there. Okay. Let's go ahead and square this. Remember, when you are squaring fractions, you have to square both the top and the bottom. So this gives me 36 over 25 plus 9 over 25. Okay, we keep doing this. We can take, this is going to be the square root. 36 plus 9 is 45. So this is going to be 45 over 25. We can reduce this fraction by dividing the top and the bottom by 5. So this is going to be 9 over 5. So it's going to be the square root of 9 over 5. And if we type that into our calculator, the square root of 9 divided by 5, that is approximately 1.34 units. Okay, remember our original estimation was 1.5 units, so that's really not that bad. We came pretty close. It's 1.34. Using a therefore statement here. Okay, so I'm going to say therefore the point -4, -6 is 1.34 units away from the line. Y is equal to 2x minus 1. And there you have it.